Good afternoon, students. How are you doing today?
Okay.
Doing good, sir.
Nice. All right. So Scripture says, "Where two or three are gathered in agreement, there He is in the midst." And not only that, He is there to bless. Time is of the essence. It matters. And I'm going to begin. Mrs. Sangram is here, and she will do some recap. But I quite frankly think that you need to go. Miss, you want to say something?
Sure. So I do agree where two or three are gathered, there He is in the midst. So we need to proceed. Time is against us.
Mhm.
So
Yes,
are we
miss.
recapping, sir? Am I recapping? Okay,
Um,
let's go. Let's
go ahead. What we can do, let me see now. Yeah, let us see if we can do about a 20 minutes recap. So go ahead, miss. Start, please.
sure, sir. Sure. Thank you. Okay, good afternoon. And God, I just want to thank you for everything. Thank you for the participants that are here. Thank you for giving us health, strength. I pray, dear God, that you will allow us to share, participate, and that you will bring to memory all that we need to bring us through this course and to exam and to be able to apply it as all they ought to be applied. Thank you for your son as we pray in Jesus' name. Amen. All right, so let's start.
Amen.
Amen. So we have 3 participants and we're starting. So just to bring to your memory, just by looking, partial derivative. How can we find the partial derivative of x of y for sin x squared y squared in respect to x and y? So just bring it back to memory. The sir will be building on what we did last class. And a quick one. What's the derivative of sin? Sine?
Cosine x. Cosine.
Cosine. So if we're doing in respect to x, how do we approach it? So which of the
So means you
go
would
ahead?
find the derivative of x and then you put back y. So you wouldn't
So
derive y. You would only derive differentiate. You wouldn't
differentiate.
differentiate y. You would only
Mhm.
differentiate x and the
All
sign.
right. Okay. And the same goes for y. You will differentiate. Okay. Nice. Are we all on the same page?
Yes, miss.
Okay. Nice, and Nikki. So we're applying the chain rule to this differentiation, right? Partial derivative. So in relation to x, to the f of x, sure, right? So we have differentiated the sign to be cosine, right? And then we're
Miss, you never
differentiating what
said
is
it.
in the bracket.
Miss, you say you were finding x.
We're finding x.
Yeah.
We're saying we're
In respect to
partial
x.
and y.
Oh,
So it's 2
okay.
of them we're doing. So it's f of x, the function of x, and the function of y, right? Let me scroll down for you to see, right? Are we
No,
on
miss,
the
it's
same
because
page?
you have f of x and then you differentiated y. That's why.
Where are you referring to? Right here
No, miss,
or
I'm not.
here?
The second line, where you have applied the chain rule, you
right?
have f of x, but you differentiated y. Miss, in the
Let
second
me
line,
see.
right there, miss,
Mm-hmm.
you have f of x and you did y. Miss, you can't just change it around, miss. You can't just change the f of x to f of y and change the f of y to f of x.
Oh, I see
Yes.
what you're saying. But f of x, which one is being held constant? When we're differentiating x, which one is being held constant?
Y.
Right, so the y is held constant here. So we put back the y square.
Miss, but you have 2y squared.
Right, because we're differentiating x.
Yes, 2y squared, but the x is to the other, is to the, means put the x in front of the y squared. We should see that.
Okay. Okay, sure, I can do that. So this one is better?
Yes, yes.
I don't like that, yes. Look at it, Tanina, and see if you agree with it.
Doubtful.
Yes, miss. That's what I meant.
Okay.
Okay.
No, miss, I wasn't doubtful. That's what I meant.
Okay.
Okay.
Got you.
Okay. Understand what you're saying. Thank you. So this
Tanil.
we're agreeing.
Tanil.
Sir?
All right. If you did it, I actually say I have OCD. You tell me say you can't see it. Who have OCD now? Me or you? All right, very good, though. Very good. Very good. All right, continue.
Very good. All right, let's continue. For our discussion, let's do question 3 first, right? Very simple. What is the partial derivative for the function for changes in x? For f of x?
Miss, which one are you doing? The one at the top?
Yes, miss.
Oh.
This
I thought it
should
was
not
two
be
different
showing as yet.
questions. Oh.
2 different questions. We're doing this question now. So f of x.
Miss, so it would be 4x cubed,
Mm-hmm.
and then you put back the plus sign and the 6 square root y because we're not differentiating y. And then the minus 10 would go to 0 because it's a constant.
Are we all in agreement with Tanil? Natalie, Shanil, and Nikki, are we all in agreement with Tanil? Tanil is saying, yes? Anyone else? Yes? What Tanil is saying, let me copy this. Well, let me copy this instead. What Tanil is saying, we would put back, we would remove, because the constant tends to 0, we'd put back the 6, the cube, the root of 6, right? And we would have, what would we have here? Raised to the 3rd, right?
4x, yes, miss.
Yes, miss.
Are we sure? What are we differentiating to? Which term are we differentiating?
X.
Is there any x in the second item?
No, miss.
No, miss.
No,
So
miss.
what is the rule there?
Oh, it's supposed to be 0. Yeah. I forgot that
Right,
when
it
it's by
tends to
itself,
0.
it's supposed to go to 0. Yes, miss.
Right. So what would be the partial derivative if it was a change in respect to the y value? Just by looking at it.
It would be the 6 square root y.
Right. That's the point. So is everyone seen? Shante?
Yes, miss. That's what you say about the Y one. If it was asking for the partial derivative as it relates to y. It would be
Mhm.
just 6 square root y.
Yes.
Means what the x can differentiate, or because it don't have a coefficient.
The x can differentiate. Yes, but in when we're doing the partial derivative, remember that a term is held constant. So once you're not differentiating that term, it is being held constant. So it's like a regular constant, like a regular number, like a number, a whole number. That is how it is viewed. So it doesn't matter if the only way you'll see it coming back, as in the example above, is if it was multiplying
How
like
much we get
here.
means if one y did there beside the x, like 4x
Yes,
to the 4th y cube y squared actually.
right. So it's only if it was being multiplied or affected by the differentiating term, right?
Yes, please.
Any other question on this item?
No, miss.
And this wouldn't be 6. We would have to work out the derivative of this item. This would not be 6, okay? But is the gist I want you to get. We would have to work out this one, right? Because remember that once you're talking about the root, it means what? It is raised to the power of a half, right? So I just want to ensure that we're getting the gist as to what we are differentiating. What's the rule, okay? And putting it into practice. Let's see how we can discuss this one, partial derivative. Any idea?
Not sure, miss.
What
Miss,
is the
which one are
principle?
we? Miss, which one are we
Question 2.
doing? No, miss. As in, which one of them are we
You. Let's start with you.
Okay. Miss, so if it's u, you would differentiate 8u2, and that would give you 16u, and then you'd put back t to the 3rd power and p, and your minus sign, and then you put the square root of v back, and then you'd put p squared back. No, that would go to 0 because there's no u
All
there.
of that will go to
It will go to
0.
0, and
Is
then
everyone
so
agreeing there? Hold
Yes,
on, Tanil.
miss.
Is
Yes,
everyone
miss.
agreeing there?
Yes,
All
miss.
Yes,
right.
miss.
Let's go to the third term now, Tanil.
So then you would have the plus sign, and then you'd have 4u, and then you'd put back the t, and then the rest of
0.
it would go to 0.
Nice. Nice. So 0 would be the last term, because everything, it doesn't have u in it. So everything tends to 0. They're all constants. Let's look at this now. Somebody else assist me with v. What about the first term?
0.
0. And the second?
Square root v, and then you'd put back the p2 and the t to the minus 5.
Right, but if we're differentiating it, so it's v raised to the,
The first
Half.
half,
okay, and then you do what? What would
Put
be
the
what would
put
be
back
the
the p,
exponent? What would be the exponent of the root of v? After differentiating it. Okay, think about it.
Minus a half.
yes miss, minus a half.
Minus a half, correct. I do agree with minus a half. And then you do what? So what is the term here? So it's minus a half, right?
Yes,
Minus
miss.
a
Minus a
half,
half v raised to the negative a half also.
right? Then you put back the p square t to the negative 5. And then what do you do with the third term?
0.
And the fourth?
It would just be that would be 1. Negative 1. Negative
Okay,
1.
Aniki. Antonio, thank you. Let me hear from two other persons. P. What would be the partial derivative?
Excuse me, please, miss. Sorry, 1 minute, please. Who is libtech? Libteech. Can you identify yourself for me, please? Don't want anybody to be banned from my class. I will drop you. Who are you? Libtech? Going once? Can you just check your name for me, please, to make sure that you are coming in with your government first name and last name? All right. So unfortunately, I'm going to drop you from the class.
Sir, I'm not sure if the person is hearing you because they're asking if Miss is talking.
Like, who are you?
Yeah, that's what I'm trying to do. Somebody that's going to wants to like John Mark, you know.
Sir, I was just thinking the same thing,
I
sir.
don't know why I believe it's John Mark, you know.
Kesana.
Oh, Jesus. All right. Continue, miss. Jesus, John Mark, I say, yes, sir, it's your stereotype, you know, sir. Never mind, Johnny. All right, continue, miss.
All right, continuing. So we are putting Heinz and Taniel in a little corner, and we're asking the others to assist me here. Just by looking at it, we're getting a feel as to what the partial derivative is, what is expected of us, right? So we're at P. First order partial derivative of the following function, F in relation to P.
Makes you would write what the AU squared T cube and 1 for the first part of the function.
Okay.
And then for the second part, you write what the square root of v t to the minus 5 2p.
Okay.
And for the third part,
0.
it will be 0.
Nice.
For the fourth part,
12
it will
p
be
to the
12
third
to
power.
the third. And for the last part, it would be 0.
Hold on, repeat the 3p. What would be the differentiation of 3p to the fourth power?
12p to the third.
P to the third power.
Nice.
The last part is 0.
0.
Okay. So let's go with T. How do we approach T now? Go ahead, Tati.
Right. 8 u to the squared, yeah. 3 t to the second power and p.
Okay.
Minus.
But be careful here. Is it just the 3 we're putting in front of the T, or are we affecting the entire
Just
element.
multiply.
Repeat that, Adiki.
We should have to multiply the 3 by the 8.
Mm-hmm.
Mm,
So
3
we
is
are
24.
Oh,
right,
yes, miss.
right. Continue. So it's 3 times the 8.
Then I put back the u
You
squared, then t
Mhm.
squared, then p.
all right. Aniki, you're still in the corner, Aniki.
Sorry.
Thank you. Go, Tati. Tatiana.
Miss minus the root of
Mhm.
b.
So the gist is we're going to times the -5 by the root and everything, right?
Yes, I don't know how to do that. Yes, I figured.
Right. And then what would be the exponent of the t?
-6.
Nice. Continue.
Miss, we reach the third term now.
Yes, yes.
Plus
We're getting the gist.
t. No, why am I saying that? 2 u squared 1
Okay.
plus 0.
Okay. All right. So this is just for us to get the gist as to what is happening. And I think we have it quite clear as to how to approach it. Okay. I'm not going to take up much more of your time. We have already discussed this. And you can take a snip of this question here. Differentiate with respect to x. We can differentiate it easily, but the other part of the question is in relation to stationary, the increase in the maximum and the minimum point. So what is the derivative here? How do you differentiate with respect to x? What would be the result here? And this is a past paper question. So Tanil and Aniki can pitch back in. So to Shante, everyone, let's hear from you. And LibTech, oh, Kesana.
Okay, Miss. So the first one in bracket is the power rule, and then the second part of the question is the chain rule. So for the power rule, you'd multiply you'd take the exponent and put it in front of the bracket,
Mm-hmm.
and then you'd reduce that exponent by 1 and to get 4,
Mm-hmm.
and then you would differentiate within the bracket, and that's going
Nice.
to be 2x, and you're going to take out that 2x and you're going to multiply it by the coefficient, which was 5.
Does everyone agree with Daniel?
Yes, miss.
Yes, miss.
Let's repeat what you said, Tanil. So we're going to take the exponent of 5
5,
and
and it's going to
multiply
become the coefficient, yes.
coefficient, right?
And then you're
And
going to
then
reduce it by 1.
the
The,
exponent
the
by 1,
exponent
so
is
it's
going to
going
be
to be
reduced by 1.
so it's going to be 4.
Yes,
But when
miss.
differentiating the brackets, you're saying it should be 2x raised to the 5th in 2x in
No,
bracket
miss,
raised
I
to the
say going
5th.
to differentiate in the bracket, so it's going to be 2x when you
All
differentiate.
right.
Yes, miss.
And everything will be multiplied by that 2x, the first set of terms, that is.
Yes,
The
miss.
first set of term. Okay, nice. So what about the plus sine 3x?
So miss,
Well,
it would be cosine. So it's going to be cosine. It's going to be 3 cosine 3x.
nice. Everyone seen that?
Yes, miss.
Yes, miss.
Right?
Miss, but you have 2 and not 2x. So
right?
that would be
Because
10x.
right, so here,
Mm-hmm.
because so this would be 2x, right?
Mm-hmm.
This would be 5. So here would be 10x.
10x. Mm-hmm.
Right. Okay, nice.
Yes, miss.
Okay. So sorry is about to come. Let's take the picture for this continuation and we can discuss it even in the chat. You can submit and we'll discuss it afterwards. Okay. I think we're all on a good start. Need additional practice to just concretize everything. Okay. So the stationary points and the increasing and decreasing points of for x. That would have been the
Okay,
next part of
miss.
the question. Okay.
Yes,
Over to
miss.
you, sir.
Thank you. All right, thank you guys. Listen to the conversation. I'm happy that you guys are figuring your way through with the partial derivative. Really very nice. Really very nice. So we're going to be talking. I need to show you a different notation. Because oh Lord, John Mark, I say your teacher, Daddy, just call your name a while again. I said, I bet you're John Mark. But by the way, boy, why you just come to my class? Let me race you. Why you just come to my class, boy?
Sir, you have to wash some plates.
Johnny, they say Jesus didn't come. And you have to tell him, hold on, me I go come. Like when you see one bus stop. And I said, no, let me drive. I see anything going to happen to you. No, man. All right, come. I'm happy that you're here, Papa. All right. Okay, guys. I'm happy that I listened to what was happening. Sir, how you can you may not join me here. Oh, I thought you wanted me to mute you. You want me to unmute you? If you want me to unmute, if your background is not noisy, I can unmute you for the duration. Cassandra, tell me if you want me to unmute you because I unmuted you first and then I read a message or maybe I misread the message and then I muted you. So let me know, Cassie, if you want me to unmute you for the duration of the class, please. All right. If she answers, guys, you can let me know because I'm gonna put my left eye on one spot on the screen and my right eye somewhere else. All right. So something came to mind a while ago when we was doing the stuff, and there are different notations. So just like we have y, I'm going to differentiate y, get dy by dx, or we can have f of x, and we differentiate f of x, we get f dash of x, and we can have g of x, and we differentiate, we get g dash of x, so forth and so on. There's another notation for Mr. partial derivative. So let me just give you one other example on the first order partial derivative before I move into second order partial derivative. That was example 2, first order. Let me create an example 3. Oh Lord, help me, I'm copy and pasting again, Jesus. But copy, paste, call this example 3, solution 3, example 3. Yes, I'm giving you let me just make up something. Say 4x to the third y squared. 4x to the third y squared. Minus 7x squared y cubed plus evaluate. All right. Now, hold on. Need to- I don't know what notation CFC will use. I don't remember seeing it on the syllabus, but I want you to just know that it's pretty much the same thing. All right, so when you look at that function, it is actually, by the way, are you seeing my screen?
Yes, sir.
Yes, sir.
All right, good.
Yes, sir.
Thank you, please. The last time I checked. What you're seeing there is what I call your squiggly y and your squiggly x. And the reason you're seeing that is because it is only a partial derivative. So it's not a full dy by dx. All right, it's not a full dy by dx. So I'm just putting that there, should in case you're seeing something like that. Let me see if I can go back to. All right, so the function is assigned, my partial derivative, I'm sorry, my multivariable function is assigned as what it is that you're seeing, and you're asking us to evaluate what is squiggly y over squiggly xx and squiggly y over squiggly yy, meaning that it's the same thing that you're doing right here. Let me just put it in parentheses here for you. Let me just put it in parentheses here for you. F of xx. All right. So if you look back at what it is that we're doing for dy by dx, don't this look like a d? Talk truth.
Yes,
Kinda,
sir.
sir, yeah.
I like that term, kinda, right? So because it kinda looked like a d, it is saying that it's only a partial derivative. It's not a full d. Something look like that. So I call it squiggly d. There's a squiggliness to it. So what it is that it says is squiggly y was squiggly xx, squiggly y was squiggly yy. When you see squiggly xx, it means that you're finding f of xx. All right. And when you see squiggly y, oh sorry, this question is a first order partial derivative. So let me change this. Let me change one of them. I wrote the question on the first order partial. All right. So this squiggly y over squiggly x, it is suggesting that I'm finding dy by dx. You know, I wanted to show you something. Hold on, let me just show you a convention. I don't need to write it for your stuff. Just allow me to show you something that I do with my calculus 2 students. And I'm not there with them just yet. That's why I don't invite you to the Tuesday, Thursday class. I may just need to get there with them enough so that I can invite you. I may just need to jump there. All right, Hsi Matrix, Hsi. I'm supposed to get a prize for write all the notes here. My poor fingerhead. All right. All right, let me just create this new share and just show you something. I don't need to necessarily show you what is happening here. So this is what is called a Hessian matrix. You're not required to know the Hessian matrix. It's just a notation I want to show you. So remember I said to you that another course I teach for the multivariable function, the students have to do X, Y, and Z. But fortunately for you, you only use X and Y. So they have to do X, Y, and Z. So it says compute the Hessian matrix for the function f of x, y is equals to all of this. All right, at the point of that. Now, they're trying to find they're given the multivariable function, which is this. Jesus. Yeah, minus y squared, right. And they need to find the Hessian matrix. Now, they're still finding f subscript x, 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 y, 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 x, y, and y, x. I don't do this part with you yet, and I don't do the second order with you just yet. We're going to do that today, and we're finishing that today, and we're starting our integration today. All right, so we have a whole lot at hand. But this is what I want to show you. When you look at the Hessian matrix for the function, it's a 2 by 2 matrix because I'm doing the second order partial derivative. This is squiggly squared f over squiggly x squared. So what I had just now on screen was squiggly xx. I could have written squiggly x squared. All right. And when I do the second order partial derivative of my x y and my yx, it could be squiggly squared f of the function f over squiggly x squiggly y. No, squiggly x squiggly y is not the same thing as squiggly y squiggly x. Well, not quite. It is the same thing, and I want you to hold on to that. It is the same thing, but the notation is different. All right? Watch up here. So you recognize that f of xy is equal to 3y squared, but f of yx is also equal to 3y squared. The notation here is different, but the results will always be the same. I want you to hold on to that because I'm coming back to that in your multivariable function with 2 variables tonight. This is with 3 variables. All right? So this squiggly squared f over squiggly x squared, squiggly squared f over squiggly y squared is just another notation that we use, right, for the partial derivative. And a generalized form, and you all were introduced to your A11, A12, A13, A21, A22, A23, so forth and so on when we're looking at our Kramers, right? So Kramers comes back into partial derivatives for them talking about the Hessian matrix of the 3 by 3. Now they will now need to move from here to compute this portion. Now this portion is pretty much the same as we were doing the Kramers. So look at this here. You notice my leading diagonal has double figures 1, 1, 2, 2, and 3, 3. Talk truth. Anybody remember this?
Yes, sir.
All right. Look at my leading diagonal: x squared, y squared, z squared. You see what I'm saying? So if I were to teach you this topic, you will recognize that there is a similarity with my 3 by 3 matrix and my second partial derivative, because this particular topic that I'm looking at includes second partial derivatives, and you know you go through all of that. These things I know you know how to do because this piece here, that is because you have done Kramers before, is just the notation that I really want to show you. All right. So let me go back to what it is that you are required to do. Just want to show you the squiggly y, the squiggly x is the same partial derivative as I just showed you just now. Why squiggly? Because it's not a complete derivative. It's a partial derivative. It's not a single variable function. Once I have a single variable function and I differentiate, I get the total differential. Once I have a multivariable function, it means that one of them is going to be held constant. because I have a multivariable function. So one or more will be held constant depending on the number of variables they are using, right? As Miss said just now, the 6 root y. When you're differentiating that with respect to x, you get 0 because when you're differentiating with respect to x, when you're finding the partial derivative with respect to x, you buck up inner one y, you know it's 0 because y will be the constant in that case, right? But whether y is married or is dating, it means that you have to respect the y. You can't just toss up the y out the door like that. So once the y is combined with another variable, the y will come back. But if the y stands alone and you're differentiating with respect to x, that y becomes a constant. Similarly, if the x stands alone and you're differentiating with respect to y, that now becomes a constant and it goes to 0. Fair enough?
Yes, sir.
Yes, miss. They are marriage. All right. So let us look at this new example. And this is just a recap before I move into the second order partial derivative. All right. So if you look at my stuff here, you will see that my x cube is married to my y squared. So there is no way I can throw any one of them out. The wife get piece of the house, the husband get piece of the house. So if you have to go use the saw like my dear did and cut the sofa in a two, I saw it to go. And in this case, at the same matter of fact, the whole of their marriage, so nobody can leave anybody. All right. So let's go. So I'm differentiating. I'm finding the first order partial derivative with respect to x. Tell me what do I write for this one? I'm finding it with respect to x. Tell me what to write.
12x squared, and then you would put back the y squared.
Very good. Everybody agrees with Tania? Because she's
Yes,
correct.
sir.
Nice. Very nice. All right. Okay, so my black screen there suggests that I'm typing the answer in, so I'll show you the answer afterwards. Now, let's differentiate this now with respect to x. What do I get?
Negative
Negative
14x.
14xy cubed.
I love the sound of that. Very good, guys. Johnny boy. I want you to open more time talking to pops. What's the next one?
2y.
Nice job. Nice job. Very nice job. All right. Can you all look at that for me, please, and tell me if you see what is happening? Everybody see that and agree with it? Agrees with it?
Yes, sir.
All right,
Yes,
good.
sir.
Very good, very good. Okay, so now let us differentiate it with respect to y.
4x cubed, 2y.
What that work out to be? You're correct, you know, but what that work out to be?
Oh, 8x cubed y.
Very good, very good. You're right, you know, Tania. Don't think that you're wrong, you know, it's just that you never multiply the 4 by the 2. So you'd have had to read another line, but very good. So 8x cubed y. Next.
Minus 371 negative 21 x squared y squared
Next
plus
job.
2x.
Plus 2 what? 2x?
Yes, sir.
Very nice. Geez, guys, I like the sound of that because we are going. All right. So what just happened a while ago is that Tania says 4x cubed 2y, but then I heard 4 2 is 8. I'm not 8x cubed y, sir. Yes. Where I want to get you guys is that I'm going to look on them little full topic here for 5 marks and just write it down. Just write it down. When I say write it down, figure it down on the paper. If it is that you want to do it in 2 steps and write your 4x cubed times your 2y and then write a third line, I have absolutely no problem. Absolutely none. This is very good. Now, I am going to be moving into, what is that now? All right. So I have absolutely no idea what I was doing here. So okay. All right. So what I want you All right, so this here, cut, and I think it should go here. Let me just check it. Yeah. All right. Okay. Whew. Oh, oh, I mean, this is something in the wrong spot because I'm saying to myself, this is not what I wrote. All right. I just had a scene a moment. Okay, so I gave it up for the sub. All right, never mind. All right, I'm right back here. Where am I? I wrote a third example just now, but I wrote it in the wrong place because I wanted it to find the first order. I wrote it in the second order partial derivative. All right, so when you see my SOPD, I'm referring to a second order partial derivative, right? And I'm in this breath, I'm going to look at the cross partial derivatives of the multivariable function as well. So what do you mean by cross partial derivative? I'm going to mix it up now and call it f of x, y, and f of y, x. So I'm not going to have just y alone here, so, or x alone here. Well, I can't have y, I can't have x, because I have y and x like I have up here. These are known as the first order partial derivative. Once I double up, it means that I'm finding the second order partial derivative. Once I double up, I'm finding the second order partial derivative. All right. So I can't double up. When I'm doubling up, I can find f of x, f of y, but I can also find f of xy and f of yx. That's what we call partial derivative, cross partial. All right. But we will get there because the cross partial is coming up. I think I wrote them somewhere. But let us just do some examples here, some exercises here. Now, this is what I want you to do for me. Before we can move to the second order partial derivative, best believe that I must do the first order partial derivative. So what do you mean by that? Before I can find the second differential, I must do the first differential. True or false?
True.
True.
Yeah, man. So because I know you now know how to do, tonight is going to be a worky class, you know. It's because I know you know how to do the first order partial derivative. I'm asking it, I'm gonna, oh Lord Jesus, but I show you the answer. That's not a good thing, Sasha. Do me a favor. I want you to find the first order partial derivative of x and y for this function. So what do you mean? You can find f subscript xy, x, xy, and y, xy before we move into the second order. Am I clear?
Yes, sir.
All right. So I give you 3 minutes. 3 minutes. All right. Teacher went for some nice coconut water for wash off him heart in the class. And guess what? Teacher feel nice now. All right. How did you get the 8, sir? Oh, it's 4 times 2. Lord Jesus, which one did I write that question? Oh, teacher Cassie. So I was differentiating with respect to y. So the 4x cubed is held constant. So when I differentiate y, I'm going to get 2y. And 2 times this 4 is 8. So it becomes 8x cubed y. Is that clear now? Just put a thumbs up in the chat, please. All right. You're supposed to be finished by now. What is the first partial derivative with respect to x?
Sir,
Go ahead. Anybody, somebody, go ahead.
sir, 12x squared y squared minus 4x cubed plus 9y squared.
Very good. All right. Let me hear somebody else know with s subscript y.
8x cubed y plus 10y plus 18xy.
Very nice. Johnny.
Sir, I have that one. I have.
Oh, me think I dry the plate them. So through me no area, I said nothing. Me think I dry the plate them. All right. Make sure they do it, me boy. All right. Very nice. All right. What about Foxy? All right.
So all along when you do this, you did have the 2x there is that that's all. Like in the
No,
question.
no. Like right there, so?
Yes, sir.
No, that we'll move on to. But before we move on to this, we have to do the 1x and the 1y first. So again, so I'm happy that you said it now. So you know, oh boy, I'm gonna help you to speak the jargon. You know, so Johnny say all along when I do started 2x, they have right there. So no. So what we're saying, what Johnny is asking, so you're finding f xx of xy. What do you think, Johnny, the double x here as a subscript is referring to? Think about it. And if you don't know, kind of say it all. But just think about it.
Yeah, derive the solution 2 times.
Very good. And what we call it? I'm going to give him a street talk, you know. Look on the something, man. You're correct, man. Tell me what you call it. Look on the heading.
What is it, sir?
Right, so.
Oh, that's the second order partial derivative.
Very good. So, you know, when I'm finding the second derivative of a single variable function, I get d squared y by dx squared. For the 1 year now, we get fxx of xy. So listen up to how we're going to do this now. I don't want anybody to blink at all. So we have f subscript x of xy. What all of this means is that I just found the first order partial derivative with respect to x of xy. And this is my answer. Now, in order for me to find the second order partial derivative with respect to x of xy, I am now going to be writing f xx xy. See right here, so? This is what I'm going to be writing. This is what I'm trying to find now. This is the second order partial derivative that I'm trying to find. So it means then that if I have f xx, it means that I now need to differentiate this function, not the one here now, this one again with respect to x. And when I differentiate this one with respect to x, what do I get? Just talk it out and tell me, please.
24x y squared negative 12x squared.
Very good.
So, yeah, that's it.
Plus 0. All right. See there? That's my second order partial derivative. In order for me to find xx, I will have to differentiate f subscript x with respect to another x again in order to get this. So watch me now. F subscript yy is going to be done in the same manner as I did my f subscript xx. So what do you think f subscript yy is going to be?
8x cubed 1 times 1, same 8x cubed, plus 10y
Excuse me?
plus, no, that's 0.
Excuse me?
Um,
Excuse me? What am I differentiating with respect to 10? Remember, I'm trying to find fyy.
10.
10
10. Very good. Continue now.
18x.
plus 18x times 1.
Yes, man. Yes, John, let me hear 18 what? 18x
Why?
don't. No, 18x. 18x. Tough truth. 18x don't.
Yes, sir,
Yes,
that's
sir.
what I said.
18x. But the x is there. Right? 18x. Very good. Very nice. Guys, be encouraged. Aniki, can you unmute for me, please? Aniki, drop asleep again. Aniki Depan, she's Instagramming. Aniki not talk. Manisha, is Manisha in class? I'm not seeing Manisha now. She all right? Anybody know if Manisha all right?
No, sir.
She's not all right, or I don't know.
I don't know.
No, man. I think just send to SOS or her. Patrine, how you stay?
Yes, sir. Understanding.
Good. Buckley, how you stay? No, any day you come in my class, and you say good evening, sir. I would call it Natty B. But any day you sneak in the class, Buckley.
Sir, me just a forward.
Oh, Jesus.
Me
The
just
train
a
of the
reach
letter.
home, sir.
Say you and Johnny must related. All right.
Sir, me just a reach home.
All right, little name. All right. All right. Foxy, you good?
Yes, sir.
All right. Let me ask a question, and I want an honest response. I heard you speaking when Mrs. Henningham was going through the stuff. And I said to myself, go on, me sip some tea now. I said, go on, my students. Yeah, man. But I don't want to leave class tonight with anybody having any cobwebs in their brains as it relates to this topic. So I'm going to ask a question. Is there anyone in the class at this stage of the game that don't see the partial derivatives? If you don't see it, say something. And remember, if you don't see it and pretend say you see it, you're stupid. I have no apologies in saying that. But if you don't see it and say, sir, here the plan, I don't see it, you're very sensible. You cannot come to the class because the truth of the matter is, when I was going to school, maybe I forget my learning here, so because me never have nobody to help me. So if you have one bigger brother, one bigger sister, or your mother and father in a position that can do them heavy maths here, fine. But if you know, say, it's you and Jesus alone, after Mr. Shanda and Mrs. Henningham done with you, and you still don't understand, but you still not say nothing, that is not very sensible. That's not a very sensible move. So please, I'm going to ask the question one more time. I want you to declare it. If you're not following, let me know, because what I'm about to do now is to just bring some question on. Matter of fact, is to have an oral class, and and in this oral class, I'm gonna be calling upon students to do the differentiation, and this differentiation is going to be done mentally. But not write it down on paper. Mental differentiation. And then the class is going to be the judge. So it means that everybody's going to participate in this exercise. So if I say something wrong, and I'm going to ask the class, is he correct? Is she correct? The class will tell me yes or no, because they are going to do it also. All right. So nobody not talk to me. Nobody don't tell me so they not understand. So I shall be moving. And I believe that you're understanding it now, but I'm just giving you the benefit of the doubt. So I don't feel any way. I'm happy that nobody's feeling anything. All right. Here goes. Here goes. So we did that one, and we get that one answer had 18y and it's supposed to be 18x. Boy. Now, John Mark, the one who claims to be cooking and then trying to wash up the dishes afterwards. This one is yours. I want you, John Mark, to find the first order partial derivative of x for me. Go. Speak it out. No writing down. Speak it out. And the students will tell you to write.
Plus 10xy minus 12xy.
Is he correct?
No, sir.
Sir,
It's the first one.
Which part? Just tell me, first, second, or third. Which part is he correct? I'm incorrect.
Sir, whenever you're not for the
The last
first.
part.
yes, sir. Ask him for a fee.
2y missing for the first one.
No man,
Oh.
the first two is correct. You know, you made a mistake with the last one. Okay, Johnny, go again, please, quickly.
Negative 12xy.
You are
No,
differentiating.
negative 6y to the square.
Very good, very good. So he said negative 12x. So he is correct now. So the first order partial derivative, you're differentiating with respect to x. It's going to be 2y plus 10xy minus 6y squared. All agreed?
Yes,
Yes,
sir.
sir.
All right. Lord Jesus, do I have that written down? Right. Very good, Johnny. Very good. So he made a mistake at the last part. Very good, Johnny. Proud of you. Because you know what we can call upon, Natty D, thinking of coming to you shortly. Natty D. Natty dreadlocks of a free some type of living. Come, Natty D, your turn. I want you to find the first.
Sir.
Natty D. D as in dreadlocks.
Yes, sir.
All right. I want you to find the first order partial derivative with respect to y for me of this function.
2x plus 5x squared minus 12xy. Yes, sir.
Hey, me really go by the tickers, you know? No, man. Only step right. Nice. I feel good. Feel good. Nice. Patrine, come on. By the way, is she correct? Even though I show you the answer.
Yes.
Yes, sir.
Because remember, you know, each of you is supposed to be doing it, you know, okay? I don't know who I'm calling upon. Patrine, you are next. Sister Pat, I want you to find for me f x of xy.
Sir, for example 2.
Say it again.
Example 2. Oh.
You're finding f of xx. This is f of x. So I'm projecting what f of x is. You're supposed to find f of xx for me now.
Yes, sir. 2y plus 10y minus 6y squared.
Is she correct?
No, sir.
No,
No, sir.
All right, Patrine, talk to me. So the class says no, and I agree with them because you're finding f of xx. So you're differentiating this function f subscript x with respect to x. So therefore, what is f subscript x of x? You're differentiating this with respect to x. Go again for me, please. What will be your answer? Come on, Petrine. When you differentiate in a constant, Petrine, what do you get?
Zero.
You get 0. All right. So what does 2y look like to you? You're differentiating with respect to x. What does 2y look like to you?
Zero. Constant.
Yeah, say no, say like you're sure. Say constant, sir.
Constant.
You know, say, sir,
Sir, constant.
Right, very good, Petrine. It's a constant. Yay, good. So when you differentiate a constant, Petrine, you get 0. So because you're differentiating with respect to x, this term becomes 0 because there is no x inside of it. This one's single. And why given x problem? So x say here the plan bossy, come out of my house because I me buy this. You are just invited here. Get out. And why can't tell x says me to buy the sofa? X are gonna say here the plan. I give you a count of 3. Make sure so by the time I reach 2, you're out. All right. Now, so you are correct. This one here is single. So because it is single, you have to be very careful because it is single. So depending on which one I want, I may give you a not. But when you're married, you're always going to be around. Just think about it like that. When you're single and you're a Y, once I'm differentiating X, you're through the gate. If you're single and you're an X, but I differentiate in respect to Y, you're gone through the gate. But if you're marriage, X and Y and X, it no matter what I differentiate with respect to the handbag, your appendage is going to be there. Whether or not you like the person, they're going to be right there. Just think about it like that. So I say this to say to you, I'm differentiating this with respect to X. This is a Y. There's no X beside it. Single, 0. I'm differentiating with respect to X. There is no X right here, so this is Y single, 0. This is married, X and Y together. So both of them going each up beside each other, can't separate. Watch me. But I'm differentiating with respect to X. So because I'm differentiating with respect to X, the Y is going to be held constant. And then when I differentiate 10X, I'm going to get 10. So it's going to be 10Y. So the differential of this is 10Y. Let me just put some things into perspective because I want you to really understand what is happening. I'm really not on social media. So if you try to put my information in on social media to find me, I'm sorry to disappoint you. You will never find me. All right? You'll never find me. However, not wrong conjunction. I'm not. I will hear a song on the radio and love this song and sing the song and say, sir, who's sing the song? I have no clue. I remember years ago I used to sing, oh goodness, oh Lord. There was a song that called My Back, My Back, My Back, My Back, My Back. And I love that song. And every time I'm walking to the trailers to the class, I am singing the song. Every day I'm walking to the trailers, I'm singing the song. And one day I went to the trailer and I reached into the classroom and then I started singing, my back, my back, my back, my back, my back. And I started singing the song and I started singing the song and the students just sat down and looked at me. And one brave student said, sir, do you know the other version? I was like, They said, yes, sir. Which version are you singing? Because there are 2 versions, the clean version and the dirty version. I said, okay, no man, it's this, and to be honest with you, that's the only thing I know. Song, my back, my back, my back, my back, my back, my back, my back. That's all I know in this song. And I'm going to tell you, curiosity wanes in because the whole time I teach people, their mommy say no, as my class, don't never Google it. And I Googled it and my ears were polluted. with languages that I don't speak. Yes, miss, the same song. No. What's the point I'm making? I can sing a song. I don't know who sing the song. And the other song that I used to sing when and my students know me by that song is oh, I think I found myself a cheerleader. Oh, goodness, crap. Yeah, cheerleader. I used to just love that song. All right. Here it is now. It's like all Will Smith and Jada, who was nominated for the Oscar.
Will.
Huh? Mhm.
Will.
Who was Jada? What was Jada's presence there?
+1.
Emotional support.
I like that one. Is it the plus one? The plus one, Kimoli, if I lick you, Kimoli, if I lick you, Kimoli, what with me and you? Foxy, don't laugh after me, right? Yeah, Jada was his plus one. Did she have to be there? Yes or no?
No.
No. And if she was
No.
absent, it would mean absolutely nothing because she was a plus one, and of course she should go along there and go make the man do something stupid and get banned for 10 years, and what if things are gonna happen to him, you know? And he's supposed to be like, you know what? You understand? And people are saying, boy, Chris an idiot. But truth of the matter is, now you look at it, who is a bigger person? There's a lot of life lesson in this, you know. Sometimes we eat up, we head down, we say, oh, we're going to defend this and we're going to defend that. Look at what is happening in the schools now. A boy this a boy, or a girl this a girl, or a girl this a boy, or a boy this a girl. And them say, oh, may I go for my ratchet and may I go for my this, we got to defend that. And then when you're behind bars and you sit and you look at it and say, but me and him are the bona fide and I'm my brethren, you know. I'm a kill my brethren. Or me do this to my brethren, you know. In hindsight, we look back and say, but I behave irrationally because we can't think logically. No, what's the point? Will and Jada are married. And irrespective of what, both of them, even though Will was the one that was getting the prize, say, for example, you're differentiating with respect to Will, Jada is there. Jada has, you're differentiating Will, but Jada is still present. But if Jada was there on her own and you differentiate Jada, Jada didn't get any award? No. So she'll be a naught. Are you seeing what I'm saying?
Yes, sir.
So when you're differentiating, once you're single, if your name don't call, you're a naught. If your name call, we can deal with you. But once you're married, whether or not your name call, you're going to be there because you're going to be the plus one. All right? Let's go. Let's go. Let's go. Let's go. All right. Kimoli, I want you to laugh after me one more time. All right, let's go. Where am I? This is 10. Who am I supposed to call now? Not calling you. I know you know it. Not calling you. Not calling you. Not calling you. Not calling. Tyree, come talk to teacher. F of YY. How do I find F of YY right there?
30 to minus 12x.
Show off. Very good, son. Proud of you. All right. Very nice. Very nice. Oh, we did. No. All right, since we did that one. We did that one in class. Tatiana, green. Find for me F of XX.
Sir, the 24 24x y squared minus 42 xy squared. That's it, miss, sir.
Is she correct?
No, sir.
No. Tatiana, remember, I asked you to differentiate with respect to x. Now, the first term is correct. Can you differentiate the second term for me, please?
Oh, would it be, sir, it would be 14xy cube, y cube.
You are differentiating with respect to x. Differentiate this term with respect to x for me.
Sir, wouldn't it be minus 14xy cube?
It means that you have not differentiated if you came at the same function. Think about it, man. If you did the first part correctly, now I know you know how to do the second part. Come on, don't get nervous. Nerviness. Come. Differentiate negative 14xy cubed with respect to x for me. Which one are you going to be holding constant, Tatiana?
The y cube.
Very good. So differentiate the other term for me now and tell me what to get.
Negative 14.
Good. So put them together now for me.
Negative 14y cube.
Thank you, honey bunches. Thank you. Sorry, Mark. Oh, this is the one I just wrote. All right, so there's another thing. Don't get nervous here. When I call upon you to talk to me in class, it's not to embarrass anybody. That's never my intention. It's not to embarrass anybody. It's just to see if you guys are understanding. So I don't want you to get nervous. Hello. All right. Foxy, what is f of yy?
There is x2 minus minus 21 squared y.
Is she correct?
Yeah.
Is she correct, class?
I don't hear what she say.
I don't hear what
I
you're
never heard
saying.
it.
The first part is correct, but the last part you kind of fumble and she not talk to me. Come, Mummy. What is? Give me the last part. The 8x cube is correct. Yes. What is the last part of the thing? Remember, you're differentiating with respect to y. Come now.
Sir, 42x squared y.
Thank you, please, ma'am. And it's negative 42x squared y. Very good. All right. Now, you see, I am going to move on because I can discern that you guys are understanding this. So I want to look at the cross partial derivative. I mean, I have others here. Don't worry about it. I will send these for you to do for class. I mean, for homework. And see, I have some stuff here. What I want to do is, all right, let me do one of these. Let me do one of these with you. Let me do one of these with you. So I now have questions involved in both first and second order partial derivative. And I give you this function. Now, let me not show you what that is just yet. So what I want, listen to what I want you to do for me now. And I'm going to call on different individuals, but I want everybody to work on the question. I'll do one of these. I've written quite a bit of them for you, and I will send you the documents. So the ones that I have not done with you, you can do them just to get your practice. All right? F of xy is equal to all of that function there. What I want you to do is to find f subscript x, f subscript y, f subscript xx, and f subscript yy. All right? So get the order. F subscript x, then y, then xx, then yy. Tanil, I want you to find for me f
Yes,
subscript
sir.
x, f subscript x. Answer.
12xy minus 4 y3 plus 1.
Plus
1.
1 who?
So I say, oh, 1y.
Okay, thank you. All right. All right, Jason. You know, so I gave you instructions a while ago, and then I have some instructions going on. All right. Very good. Shante, my instructions just now was off because that's not how I typed the question. Shante, I want you to find f subscript x for that for me now, please.
Sir, 12y.
Okay. Good job. What is wrong with you tonight?
Sir,
Yes, honey.
sir, when you say you want f subscript x, isn't it a case where you want x and then y is 0? Everything. Sure, but what I'm gonna say f subscript xx. Sure, wouldn't that be 12x and then y is 0? So it'll just be 12x.
She's differentiating with respect to x. So she has already f subscript x, and she's finding f subscript xx, not xy. So what it is that she's doing is differentiating this function again with respect to x to get f subscript xx. So these subscripts are telling you how many times I'm differentiating the function and what it is that I'm differentiating the function with respect to. So
yes, sir. So when you're differentiating with respect to x, isn't it a case where you want x?
Right. So watch me. So you're differentiating with respect to x. That means y is constant. It goes to 0. Talk through.
Yes, sir.
Right. So this goes 0 and this goes 0 down.
Yes, sir.
Very good. And we're differentiating with respect to x. So the y is held constant. Remember, this is Jada, a Jada this. But I'm not sure that, not matter. See me right her back. And then now I'm differentiating my 12x. When I differentiate 12x, what do I get?
I understand now.
Good job. Good job. Good job. Aniki, can you unmute for me, please?
Sir.
Me notice something with you, You don't want to talk in my class, but Miss Henningham, when Miss Henningham teacher, you're our best friend, I'm going to go on tell you, say, I feel a way about that. Allow me a call if you unmute, Aniki. Me and you is not friend today. All right, come, Nikki, your turn. Teacher love you here, teacher trouble you. Come, your turn, Nikki. F subscript y. Do F subscript y coming here, Nikki?
6x squared minus 12xy squared plus 16y plus x.
Show off. Show off. You see, she just run through this something, Miss Henningham? Jesus. Show off. Nikki, that was very good. That was excellent. That was excellent. By the way, you all agree with her?
Yes, sir.
That was excellent. Wow, jeez. Come, Natty B, your turn. So she has given us, what I did was to write it in stages. She has given us, oh Lord, I think you're seeing this piece. She has given us F subscript Y. I want now you to find F subscript YY for me, Natty B.
Say from which one? FY?
F subscript Y, yeah. But this piece up here, so, is just a breakdown. It's just right. So this is what you need to be using.
Okay.
Go ahead, Mohan. F subscript YY.
So negative 24 let me know that part there.
You are on the right track. Continue.
Okay, negative 24 XY.
Yes, ma'am. Sure.
Plus
Continue.
16Y.
Listen. If I put across my lap and beat you, see, mommy, you did the first part correctly. Do the second part. No, the second part is easier, mommy. Come on, man. You're different. Duh. Duh. All right. Should I tell you very good? You just need to be confident. You can do it, you know. You just lacking the confidence. Very nice. All right. So what? Recall that you must use the first derivative of the original function in order to evaluate the following. Now, Kimoli, you see, because you laugh after your teacher, I left this one here for you. Because you laugh after me, you roll over, you know, roll over, floor and drop, you know. You drop and roll. All right, still love you. Let's go, Nick. Kimi. So this is now, so look at my recall. You must use the first derivative of the original function to evaluate the following. The following cross CROSSPARTIAL. That's good wrong. DERIVATIVE. So I want you to use the original function to evaluate the following cross partial derivatives. Following derivatives. All right. So Kimoli, this is what teacher wants you to do for him. You are going to be looking at F subscript X. And because it's a cross partial, I want you to differentiate this function here with respect to Y for me. Listen to what I'm saying. F subscript X, and you're going to differentiate F subscript X with respect to Y. So you're going to now evaluate F subscript XY. Evaluate this with respect to Y for me, please, Kimoli.
There you said to differentiate it with respect to Y.
Mm-hmm. You're cheating, you're writing it down, and you're not supposed to write it down. You're supposed to do it.
Sir, why not?
Because I told you not to. So you're being disobedient.
Sir, you told me that after I wrote it.
Come,
Sir, 12x minus 12y squared.
And?
And?
I asked her to differentiate this with respect to, is she correct, class?
Half right.
Half right. Can you differentiate this function now for me, please, Kimoli, with respect to Y? Oh, she's all right, thank you. Come on, Kimmy, man.
Sir, I'm confused.
No, don't be confused. You're correct, you know, just left out something.
Sir, what did I mean? You do the Y at the end.
You never do the Y at the end.
Sir, but
But what? But what? Tell me now. Tell me now. What is the answer now, mommy?
12x minus 12y squared plus 1.
Again, tell me, sir, record. I will
Sir,
call
no,
me. No.
sir, I
Me
can't
will
do
call.
that.
Me will call
Sir,
Mr.
no.
Record.
Sir, no.
Matter of fact, to show you how serious I am, I'm going to send Mr. Record
Sir,
a voice
if
note.
you do that, sir, you don't rate me.
No, man. But guess what then? Me not rate you, because me going to load you up with Mr. Record now. Mr. Neville Record. Let me see if I can find him. Uncle Neville. Uncle Neville. All right. Here goes. Uncle Neville, guess what? Kim Molly just make a grand mistake in the class, you know. Uncle Neville, I want you to beat her when it's here for class. All right. You can call her and ask her what mistake she made, Uncle Neville. Sent. I still love you, but I'm setting you up. You suppose, when you go to school, and your teacher, and you do something wrong, and teacher still love you, but teacher said write 100 lines. Hey, them still get them something at school though? Or detention still work, miss? Detention. What is detention? Anyway, let's go. But very good, Okimoli. Yes, it's going to be 12x minus 12y squared plus 1. Very good. Very nice. All right. Now, who should I call upon? Who should I call upon? Javier, why are you hiding? Why are you hiding from teacher? Javier, look at what teacher wants you to do. I don't have what this is written. I need to put F subscript Y again here so you can see what is happening. Copy, paste. All right, Javier. Here one this now. F subscript Y, Javier, I want you to differentiate F subscript Y with respect to X for me now and tell me what you get.
Sir, 12x minus negative 12y squared plus 1.
Very good. Now, there is something that we need to talk about. Very good. Very good. Pair of you and Kimoli, the one who laughed off the teacher tonight in class. You recognize that F subscript Y and F subscript XY and F subscript YX results in the same answer?
Yes, sir.
Yeah, man. Results in the same answer. Hear me out now. Where sir is building us to get to is to evaluate the stationary points of the multivariable function. Just like how we did stationary point for single variable. Oh, congratulations for those of you. I know Kimmy can't make it out on a Saturday, but I know Kimmy's understanding. But trust me again, guys, you guys turned up. I mean, I had to be shuffling what it is that I'm doing with the business calculus students just to facilitate your learning, since I have a little bit more time with them than I have with you. And I am honestly thinking that I'm going to be doing the same with the calculus 2 students that I may just invite you guys to come again. I'll work that out in my headspace. I'll let you know. But congratulations. You guys turned up for the stationary points. And I mean, you guys, for the most part, got it. Let's go. Let me just pause and say something here. So if they were to ask you about to evaluate the stationary point of a multivariable function, here are some very easy marks to pick up. Evaluate the stationary points of the following multivariable function, f of xy is equals to rate t. The first thing you're going to do is to find f subscript x, f subscript y, f subscript xx, f subscript yy, f subscript xy, f subscript yx. But sir, why we have to find xy and yx at the same time? If they're going to give you the same thing. And I keep saying to my students, You see, the moment you find f subscript xy and you get your answer, and then you do the same thing for f subscript yx, and both of them come out to be the same thing, it suggests to you that your f subscript x, your f subscript xx, your f subscript y, and your f subscript yy are correct. If when you did these two down here, your f subscript xy and yx, and they result in different answers, sitting up your soul, wrong.
So you're saying they're always going to be the same thing?
Every single time, yesterday, today, tomorrow, and forever, they will be the same thing. Real talk. Real talk. So I keep saying to students, you know, sometimes the exam body don't ask you to find, they will ask you to find f subscript xy. Me always tell students, find the yx, because when you find the yx and you get the same answer, you know your question right. You know, one of the things that I'm trying to work with you on is that the areas that we have covered, the areas, and this is why Mrs. Henningham's presence is very important in terms of her reinforcing what Sir you know, would have completed. Because our aim is to get you guys the areas that you have already completed, that you maximize those points. Because there's coming a time when I have to be rushing through the upper unit. And I'm not saying it straight up. So I want you to be able to maximize. When you get them questions, just box it up and put on your marks. Right? So I'm saying to you, they may not ask you to find a stationary point, you know. But if they will ask you to find a stationary point, hooray. But if they ask you to find a stationary point, you know exactly what to do. Always, when you find f subscript xy and you find f subscript yx, if the pair of those two second order cross partial derivatives give you the same result, you know, so your first order partial derivative and your second order partial derivatives are correct. Fair enough? Now, everybody saw what we did right here. So in order to evaluate, to turn up at my cross partial derivative, right here, so I'm talking about my cross partial derivatives. These are my cross partial derivatives. Cross partial because, of course, you know, it's multivariable function. So once it's multivariable, we talk about partial derivative. And cross partial mean that it is x and y and x. Tell me if you get that.
Yes, sir.
Yes, sir.
Sir, say differentiating based on the ones that are closer to the equal sign.
Oh, thank you, please, dearest, because that's exactly what I was going to say to you. Yeah, man. All right. That was my final point before I move into the stuff. So remember now, when we are
I
finding,
never get it. I never get it.
You never get what you said a while ago. All right. Let me. I'm about to explain it again. I was going to reinforce this point, and then Daniel came up with what I was going to say. F subscript xy. F subscript xy. It means that the one in front is what I'm going to start off with, and the one at the end is what it is that I'm differentiating with. So every time I look at the end one is what I'm differentiating with. The first one is what I start off with. So look here. You have f subscript x. You're finding f subscript x. In order for you to find f subscript xx, it means that I must start with f subscript x, and then I'm differentiating with respect to the other x. When I find f subscript y, in order to find f subscript yy, I'm starting off with the first piece, which is f subscript y, and then differentiating f subscript y with respect to y. When I'm finding when I'm finding f subscript xy, it means I'm starting off with the first piece, f subscript x, and then I'm differentiating that with respect to y. When I'm finding f subscript yx, it means that I'm starting off with the first piece, f subscript y, and then I'm differentiating that with respect to x. Am I clear?
Yes, sir.
Yes, sir.
Very nice.
Yes,
Very
sir.
nice. Very nice. Very nice. All right. You wouldn't understand what I'm feeling right about now. Do me a favor.
Sir, overwhelming.
I'm just feeling very happy because I mean you guys are getting it, and I mean as long as you guys are telling me the truth, I'm just feeling very excited. But I will know because I'm going to be calling upon different ones of you to tell me the answers here. I have a new function, f of xy 5x squared y plus 6xy squared plus 3x squared minus 7y. I'm going to ask you to find all 6 of them. F subscript x, F subscript xx, F subscript y, F subscript yy, F subscript xy, and F subscript yx only. On your mark, get set, go. I'm giving you 4 minutes. I'm going to get something to drink. I'm stepping away. Okay. All finished now?
Yes, sir.
Yes, sir.
Very good.
Yes, sir.
Very nice, Johnny. Where is Matthew? Hey, Matthew, you make me follow to me. Seriously. Right. Good adoption. Good adoption. Tariq. F subscript X. Your answer is?
10xy plus 6y squared plus 6x.
Is he correct?
Yes, sir.
Yes, sir.
Yes, sir.
Very nice. Very nice. Nathaniel, you just came to class, Nathaniel? Paul?
No, sir, I was here earlier, but I had to leave and I just joined,
Okay.
rejoined.
You understand what is happening?
No, sir.
No, you shouldn't. I mean, I don't expect you to because I went through my participants list and I didn't see you at all. Anyway, see if I can track it, Shawnee here. Patrine, Tariq was very correct a while ago. Follow you, Tariq. Very nice, Papa. Went by a bag juice, a Carl's bag juice and a banana chips. Very nice. Patrine, come. F subscript XX only, please.
So 10, so 10xy plus
Patrine,
hmm,
Patrine, come.
answer.
Serious now. So look at the screen here. You're seeing S subscript X. S subscript X. And I'm asking you to differentiate this function with respect to X for me. How you started a while ago, you started off on the wrong foot.
Oh, sorry, my bad, sir.
Come. Differentiate that with respect to X. I know you know, so come.
So 10x plus 6x.
Should I turn on my camera so you can see my face?
No, sir.
Okay. You know what kind of face I have? I have a maximum look on my face. What is a maximum look on my face? What kind of face is a maximum look? You know, guys, what is the maximum face versus a minimum face?
Frown.
Right. So the maximum face is a frown. So I'm frowning now, Miss Pat. Come, talk to me now. Come. And I don't want anybody to help her. She's going to get this tonight. So Tariq gave me 10xy plus 6y squared plus 6x. I want you now, Patrine, to differentiate this function for me with respect to x to find f subscript xx. What is the differential? The second order partial derivative with respect to x. What is it? Come on, I'll try it, mommy. Try it. Come. We're here to learn.
So 10y
Okay.
plus
What is between? 10y is correct. Are there any other terms?
10y plus 36y.
What are you differentiating with respect to Patrine?
X.
Okay, so why are you differentiating the y, Patrine?
This is 10y. And then that would be 0. And then so isn't the 10y?
Okay, don't tell me 10y again because that part they're right. So yeah, that part you're right. 10y right. The part is how much, Patrine?
0.
Huh?
So 0.
Very good, Patrine. The one you're right too. So don't tell me about them two parts again because you get them right. Which is this part, Patrine? I'm differentiating this with respect to x. What do I get, Patrine?
So
Is one of two, is one, where is it? I'm coming for you. I'm coming for you, and let me tell you what. I'm coming for you, and I'm going to shake out your lunch money for the rest of the week. I mean, Mrs. Henning and myself get back curry lobster out of it. I will not argue on. Differentiate 6x with respect to x, so mental to get Patrine. Yeah. So why not telling me? Patrine, you're joking with me. All right. Huh?
I don't feel well. I'm trying, sir. I really don't feel well.
You don't feel well?
Okay. So I'm working on half a brain right now.
You doing what?
So I'm working on half a brain.
You're working on half a brain. All right. I'll tell a story. It's all science students, and this story is very relevant to you. It's all science students, every single one of you in here who are a science student. When you go to university, there are 2 university courses that must be completed. In my days, we call it UC 120. We must call it Foundational English or something like this. Something no. There's an English university course that must be done. Foundations of English, FC, yeah, Foundations of English. That must be done. It must be done. Whether or not you pass in English, it must be done. There's another course that must be done. If you are like me and never liked history and was thankful that history was merged with another subject when in high school, so you just move to the other subject because history is not what you went to do. And I thought I got rid of that subject. Oh Lord, I felt full until I buck up in a university. Oh, you didn't do history, you have to do development of civilization. Oh Jesus, that's so many years ago. Or something like so. Yeah, something like so. Yeah, development of civilization. Something like so. Yeah, one of them history courses. I couldn't even spell Amerindians. Couldn't even spell Amerindians. But when I was studying them, give me bigger words than Amerindians, and I could have spelled those. But the way I did not like history, I couldn't even spell Arawak. No, I just never liked those courses. Never liked them. And guess what? And I may have told you this before. When I went to university, I don't know how many of you knew about Lime Tree Lane with Mas Gossi and Miss Zella and all of them characters there. They were on campus with me and they were in the same history class with me. Very nice class members. And they said, so you ready for the exam? I said, I'm not doing the exam. They say, why? Are you doing class every Friday night? Every Friday night, you know. They say, yeah. I don't like the subject, you know. So I come to the class 1 year before, so I can use the whole summer and study it. So come next year, I can do the exam. And I remember Tiny said to me, boy, if I lick some sense in I see your mother feel it for you. I said, okay. And Miss Zella said to me, so, oh, you mean you now do the exam? And the whole of them come and say, you try go get registered for it. And I said, but how do I talk to me so strong? He said, they don't know me from nowhere. I only knew one of the class members, Mas Gossi. And he was a designated driver. So the whole of it, God forgive me again. I'll 10 of it in a one car, go down an arbitrary on a Friday night. And him said, no, go get registered. And I got registered for the course. The exam was the Monday afternoon, and I got registered for the course the Friday evening. I went through hell to get registered for the course the Friday evening. And I did that course. And I didn't even know that I passed the course because when the results come out, me say, in my book, it was either A, B, or C. But when I look at my ID number, I say P, I say rock stone. No one them couldn't even find my F and give me. All the way down the alphabet P, I say, I'm a fool, not duck. And somebody looked at me and said, no, you're really a fool because P means pass. And I went back and look again. I'm going to look and see there's something at the bottom and say P means pass. So it was a pass or a fail course. And I passed it. I'm going to tell you why. It's important for me to share that with you. I hated that course so much that I was not going to find myself in that course again. And even though it was a university course, it no matter how much A's you get at university, you can't graduation if you don't pass these university courses. So I say this to say to you, we have to be working and working very hard at what it is that we're doing. All when your brain half a work. Nobody make me for call upon you and talk to you so long for free. Just give me the answer and say, all right, enough of stir now. Come on. I really want, and for those of you who did CXC history and believe say, oh, I don't have to do that, there's another, for those who pass history, there's another university course that they give you to do. I can't remember now because I've been to there for so long ago. Can't remember, right? But there are going to be 2 university courses. So even if you're a medical student, because I was in class, I can tell you I was in class with some medical students, they too have to do these courses. Engineering, you have to do the courses. Hospitality, once you are a university student, you have to do the courses. So I'm saying to you, put in your headspace at this point in time. I may not like a particular course, but I'm going to do it and get through with it because I'm not doing the course again. Some of you may not like the integrated math. Guess what? I want to get this associate degree from CXC because if you not pass the integrated math, you can't get the CXC associate degree. That are the point I am making. So because you want to get, just like me, you want to get the degree, you don't want to get the associate degree. So you have to pass the integrated math. Put your mind and your heart to it. All right. Very good. Thank you, Pat. Thank you, Tyree. Johnny, F subscript Y for me.
Uh, 5x squared plus 12xy minus 7.
You know, so sometimes I feel like we just want to knock you over in our head because you can't be working but you're lazy. That's very good, Johnny. That's excellent, as a matter of fact. Very nice. I'm really very proud of you. Keep up the good work here, Papa.
Yes, sir.
Yeah, man. Very nice. Very nice. Really very proud of you. All right. Nathaniel. All right. Let us try you now. Are you getting the gist of it now, Nathaniel?
Yes, sir.
All right. So, Johnny, in show of 3C, you just run through it 5x squared plus 12x minus 7. Very nice. Very nice. I want you now to differentiate this function for me with respect to y again. So you're going to be finding f y y for me. Try that one for me, please, son. Hello. Come on, Natty, talk to me now. Nathaniel, you're muted. Do you understand what to do?
Sir, I'm not sure.
Yeah, but don't mute. Say to me that you're not sure. Don't mute on me. All right, continue watching what is happening, please. They may have to pull you out to work with you, but continue watching, please. Shan, Whitfield, what is f of y? With fields
Sir?
come, man.
Oh,
F of
oh,
y.
sir, I have 12x.
Good job. Proud of you. Very nice. There's a reason I'm doing this, guys. There's a serious reason I'm doing this. I really want to make sure that you guys are getting it. I could have moved on a long time ago, but I really want to know that you guys are getting it. And so far, I'm pleased. Maybe just one or two, but I'm pleased. I'm pretty pleased. I'm not going to complain. All right. So I know you know it. So I know you know it. I know you know it. I know you know it. All right. Okay, Tani, give me f subscript xy, please.
10x plus 12y.
Good job. Shante, is she correct?
Yes, sir.
All right. So technically, what I just asked you a while ago, Shante, was to do 10f of yx. All right, very nice. Let me ask a question because I want to move into something else. Because this is now 7:36. I have an hour plus. Please go ahead.
I'll get that.
Oh, we get what?
The 10x plus 12y.
I'm differentiating with respect to y. Now remember what Sir said earlier. The last one is what I'm differentiating with respect to. So I'm going to be looking at the first piece. I'm looking at my f subscript x and differentiate it with respect to y. So I'm looking at f subscript x. F subscript x up here, so. And I'm differentiating this piece with respect to y. So that means my x is constant. I'm going to differentiate y, I'm going to get 1. So 1 times 10x is going to give me 10x. I'm differentiating with respect to y. 2 times 6 is 12, so I get 12y. See it right here, so? I'm differentiating this with respect to y, but this one is on marriage, standalone. And I'm differentiating with respect to y. This one is a constant, it goes to 0. You see that?
Yes, sir, I'm seeing it.
All right. No, don't mind. No, not finish with the 20 bunches. You get brought up. So now I'm finding f subscript y x. See it right here, so? It means that, I know why I color coded it. It's a f subscript y. We're looking for f subscript y up here. And it's the last one that we're differentiating with respect to. So it means that I'm differentiating this with respect to x. 2 times 5 is 10, so I'm going to get 10x right here. See it right here, so? I'm differentiating this with respect to x. So it means that my y is a constant. So I'm going to write back the y. I'm going to differentiate 12x, I'm going to get 12. And this constant here goes to 0. You like the brought up?
Yes, sir.
Nice job. All right. I'm confident. I feel good. I'm going to give you one more for the road, and then I'll complicate the question just a little bit more. I'm giving you that. Giving about 4 minutes to complete the 6 calculations for me. And then I'm going to move into the stationary points now of the multivariable function. Start for me, please. Anybody finish?
Yes, sir.
Yes,
Very
sir.
nice. Very nice. Very nice. Woo, sounds good. Nikki, finish? Johnny, finish, Papa?
Yes, sir.
Yes, sir.
Kimoli, finish? Who's next? All right, let's go. Just tell me the answer, please. What is F subscript X? Anybody?
Sir,
Mm-hmm.
4 x y squared plus 6y plus y.
Oh my goodness gracious. Oh Lord. All right. Was that what you told me? 4x squared y plus 6y?
Yes, sir.
And then everybody agree with the 4y cubed, 4y squared?
Yes, sir. Yes, sir.
All right. Everybody agrees with my f of y and f of y?
Yes, sir.
Yes, sir.
Very nice. And everybody agrees with my f of x, y, and yx?
Yes, sir.
Yes,
Yes,
sir.
sir.
If them your two not are the same something, it means then up two up yes are wrong. All right. Very nice. So I have many more questions, as you can see, a whole lot of questions that I have here for you. This is what I want to move into now, though. Very nice. So we need to look at some stationary points. And I'm going to go through this with you very quickly, give you a few to do, and then hopefully I can, well, not a few. I will work through one with you, give you one to do in class, and then I can touch on the integration. So it says, okay, so here it is that we are now looking at stationary point of a multivariable function. We looked at the stationary point earlier for the single variable function. Let us see if there are any similarities with this here. We need to differentiate the function f of xy to obtain f subscript x, xy, and f subscript y, xy. Do you know how to do this?
Yes, sir.
All right, good. Then you're going to set the differential equals to 0. But hold on, sir. Are the same thing. For the single variable function, we differentiate the function and then we set it equals to 0 and solve for the values of x. In this here case, it's going to be the same thing. But because we're talking about a multivariable function, we're going to set f subscript x of xy equals 0. Similarly, we are setting f subscript y of xy equals 0, then solve for the unknown simultaneously or otherwise. And this will give us the critical values. All right, the result together yields the stationary points, critical points or turning points. Remember, all of them mean the same something, and it's going to be written in the form a comma ab. So remember, when you solve a pair of simultaneous equation, remember again solve for x, the unknown in this case, and we also substitute that into that to solve for y. True or false? No answer? Is that a false or a true? Okay, good. All right, so now to classify the nature of the stationary points, suppose a comma b is a critical point from up here, so of the function f of xy, and that the second order partial derivatives of the continuous region contains a comma b. Watch this story. D of AB is going to be equal to f of x AB times f of y AB minus f of xy AB all squares. So what is? You're going to evaluate your f of xx. You know what your f of xx is because you would have calculated your f of xx. You're going to substitute your critical point. Remember now, I said suppose AB is a critical point. You're going to substitute your critical point into the function. Then, sir, now that we used to do for the single variable function. But for the single variable function, because it is single variable, is only x alone we substitute. But because we're talking about a multivariable now, we're going to substitute both x and y. So we're substituting our values into the f of xx and in f of xy, as well as f of yx or xy. Remember now, xy or yx will yield the same result. If d is greater than 0, sir, bigger, no maximum, I mean minimum. Same thing like the single variable function. But guess what? F of xx must also be greater than 0. So we need to look at the value of f of xx, and once it's greater than 0, then we have a relative minimum. If d is positive, but f of xx is negative, then we have a relative maximum. And once d is less than 0, we have a saddle point. For the single variable function, if this is equal to 0, then it's a saddle point. But in the multivariable function, once it is at d, this d here that we evaluate is negative, you have a saddle point. If d is positive, we have to double check our f of xx. If your f of xx is positive, it's a minimum. If it is negative, it's a maximum. This is all that this is saying right here. All right. And then if d is equal to 0, guess what? We can't do the question because it could be relative minimum, relative maximum, or saddle point. We have to go use something else that sir now teach you in order to resolve that. And we're not going to do that. All right. So, am I clear right here? Is this difficult? It's 2, 3 easy something to remember. You differentiate the function f subscript x, f subscript y, set both of them equals to 0 because they have 2 equations with 2 unknowns we can solve simultaneously. Sometimes it's going to be a linear, sometimes it's not going to be linear. But you know, sir taught you how to solve simultaneous equation. That's why I had to teach you simultaneous equations first before I move here. When you solve your simultaneous equation, you're going to get both x and your y. And then now you're going to just look at your xx. When you substitute the critical values, if xx is positive and d positive, you have a minimum. D positive and xx is negative, you have a maximum. Less than 0, you have a minimum. All right, so I have a good question here for you. I have a good question. Go through and find all 6 of these things that were just fine a while ago. I told you I was going to do one with you, but I forget to know how to do the 6. So find your f subscript x, 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 y, 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 x, y, y, x. When you finish finding those, then I'll work through one of those. I'll give you 5 minutes. On your mark, get set, go.
Sir, where's how we find f subscript
The
x?
same 6 things. The same 6 things you're finding.
fx, fy, fxy,
Yeah, man.
fyx. Okay.
Same 6 something. Yeah, yeah, yeah. X, 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 y, 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 x, y, and y, x. Yeah, man.
Finish, sir.
Very nice. Anybody else finish?
Yes, sir.
Mm-hmm. Waiting on the others.
Finish, sir.
Yes, sir.
Nice, nice. Come on, come on, come on, come on, the rest of you.
Hey, madam, may I check it?
Can I go now?
Yes, sir.
Look at me. First order partial derivative, second order partial derivative, and a cross.
Sir, I was so confused. Oh, it's because I did it different.
Yeah,
So
yeah.
I did all my X's, then Y's, and then the cross.
Fair enough. Fair enough.
Sir,
Yes, sir, that's what I have.
Thank you very much, Tantan. Yes, please.
sir, me no know for the XY, me get 6Y. Me no know where that come from right now.
XY got 6Y?
Never mind. No, never mind.
Okay. Is there any one in the class that... Tati, say it again.
Sir, I got these correct.
Woo! Nice. Johnny, you know me go call upon you. I mean, now leave you alone. Come, Papa, son. Well, wait again.
Same thing, sir.
Very nice, Papa. Very nice. Very, very nice. Very nice. Brother, you son. All right. Now, I want you to just pay attention now. So, you see, you get a number of marks, right? They say no. Get a number of marks. So, remember, we need to now set my first order partial derivative. Remember, the first one in set equals to 0. I'm going to solve simultaneously. When we solve simultaneously, we're going to solve for the value of x and y. And then we're going to substitute it into the formula. Remember the formula? F of xx ab times f of yy ab. AB is just a critical point. Minus f of xy ab all squares. If d is positive, it's one of two things. It's either it's a relative maximum or relative minimum. How do you differentiate, sir? If f of xx is positive, you have a minimum. If f of xx is negative, you have a maximum. If d is less than 0, you have a saddle point. If d is equal to 0, it can't work. It cannot work. All right, let's go. Simultaneous time. Recall for critical points, dy by dx is equal to 0. So therefore, let f of x, f subscript x of xy equals 0, and f subscript y of xy is equal to 0. This one here is linear. This one here is quadratic. That one is linear. That one here is quadratic. So we're now solving simultaneously. Now, looking at the first equation, we see that 6x is common to both. See, I highlighted there. Do you agree or disagree?
Agree.
Agree.
Yeah, man. So because it's anytime you look at one equation, I say something similar or is a factor of, we're going to factorize it. Remember that the single variable function that I did the differential, and then I set it equals to 0, and I recognized that 6 was common, and I divide through it by 6. You remember that one?
Yes, sir. I think so.
Yeah, man. You should remember that, because we did that, and I think we had a conversation around it. It's the same thing right here. So because 6x is common to both, we're going to factorize the 6x. Now look at what I'm doing. I'm factorizing the 6x. So I'm going to have 6x times y minus 1. So I only get minus 1 because I'm taking 6x out of it. Remember, any whole number is being multiplied by the multiplicative identity, which is 1. So I'm going to have 6x times y minus 1. So it's one of two things. Either 6x is equal to 0, bam, or y minus 1 is equal to 0. Remember again, I did a question, and who was it? Somebody in the class said, sir, I don't understand where the 3 went.
Sir, it's me.
All right. So you see, you remember, I don't understand how sir remember all I did something here, but very good. So you see why questions are very important to be asked and asked in class. And then I said to you, it's one of two things. Either 6x equals 0 or y minus 1 equals 0. Now you tell me, can 6x be equal to 0? No, can't equal 0. So therefore, it's either x going to be equal to 0. All right? So x itself is going to be equal to 0, but y minus 1. Right? Y minus 1. So if 6x is equal to 0, it means that x equals 0. X has to be equal to 0. All right? But if y minus 1 is equal to 0, it implies that y is equal to 1. So now, for the first equation, then sir, are you solving this simultaneous equation like this? Because this simultaneous equation, it so happens that I can factor out an x value and a y value in my linear equation. Now I need to do something with the quadratic. Note, always factorize and resist the temptation in Jesus' name, hallelujah, amen, of canceling the x's. Me don't want to see nobody cancel out no x, because if you cancel out the x, you will miss this value and just write x equal 1. I don't want to so do it. And I'm going to show you how to do it normally. Please also note that in Jesus' name, that is not the critical point, but a critical value. We are now forgetting equation 1 and we'll be using equation 2. We have no interest in equation 1 again. None whatsoever. Watch me. We are solving simultaneously now, but must use a substitution method based on the nature of the equations. Please note, one equation is linear, while that other one, very ugly one, is quadratic. Recall the rule says that we must substitute the linear equation into the quadratic one. Anybody remember anything like this that we talked about now?
Yes.
Yes, sir. Sir, is that when you made the equation 3 or something like that?
Very good, very good, very good. All right, now, so watch me now. I need to clarify something up here. So, you see, teaching is my life here. I've been doing this for ever so long. It becomes part of me. All of me I sleep, me I teach. Real talk. Copy. And I just want you guys to understand what not to do is this is what not to do. So some of you may be tempted to say 6xy minus 6x, or you're going to put all of this equals to that, and then you're going to cancel out the 6x's and then say y equals 1. Can you see this?
So repeat.
Now I'm saying this is what not to do.
Oh, okay.
Some students may say 6xy is equal to 6x. They add 6x to both sides. Some students may be tempted to do that and then cancel out the 6x. If you cancel the 6x, all you're going to be left with is just y equals 1. This is what I'm saying to you. You know what? What not to do? Cut. This is what I'm talking. This is what I'm referring to right here. So that's what I'm referring to. All right. So let's go now. So remember, when we're solving a simultaneous equation, we always work with the linear function and substitute the linear function into the quadratic, which is why I started off with the linear function first. Now, having worked the linear function and got x equals 0 and y equals 1, I'm substituting anywhere in the quadratic function. You know, I'm going to get into the habit of putting I changed it to nonlinear, and let me tell you the reason behind me changing it to nonlinear. Even though this is a quadratic equation, you know, but it is also nonlinear. So I can call this quadratic, or I can call it nonlinear. But there are times you may get a function based on the derivative. You could get 3x squared y. 3x squared y would not be a quadratic. It could be a nonlinear function because it will have an x times y in it. All right, so let us not call this quadratic and call it nonlinear. And then no. Come on, insertion. Remember, we try to teach you conceptually. So whatever they give you, you're supposed to be able to read. Nonlinear. All right. Note one is linear while the other one is nonlinear. We'll call it rule so that you must substitute the linear equation into the nonlinear equation. All right, good. All right, I think we've taken that. All right, so x is equal to 0. We're substituting x equals 0. Anywhere into the other functions. See here? F subscript y, anywhere there I see x, I put 0. See it right here, so? Anywhere I see x, I put 0. So what happens now, this goes to 0. Oh, the same thing I asked you not to do up top. I put it right here, so also. Where am I? Yeah, so I substitute in 0. That goes to 0. So I'm going to be left with 3y squared minus 6y equals 0. And then what I'm doing here, I'm factoring out my y, because remember now, once you can factor out something, once there's something that is common, always get into the habit of factoring it out. Once something is common, just get into the habit of factoring it out. Trust me. If you follow my leading, there are going to be times you don't have a clue where to go next, but because you know the sir say always do this, when you do it, you will see that you're closer to the solution. Once it is that you have something that is common, take it out. It is cluttering what it is that you're supposed to be seeing. So 3y squared minus 6y, something come into something. So I'm taking up the negative 3y. What is going to be left is y minus 2. Oh, but sir, I see, no. Similar to the one up top, sir, either negative 3y is equal to 0, therefore y is equal to 0, or y minus 2 is equal to 0, Therefore, y is equals to 0. I mean 2. Mm-hmm.
Sir, why you have -3 outside and -2 inside? Isn't one of them supposed to be positive?
And you are correct too. Let me just say, yeah, you are correct. You are correct. You are correct. It's supposed to be a positive 3.
Yes,
you see I have the
sir.
positive you see I have the positive 3 right here, so I don't know
Yes,
who copied and pasted. So no, it's not actually no. See, it's not even in my stuff. Look at this. This is funny. You notice my box is highlighted outside of it. I don't know if you can see my box is highlighted outside of it, so I don't know where that negative sign comes from. All right, thank you. But yeah, it wasn't there. The correct thing is right here. So 3y. Thanks for following. Now, I want to just point out something to you. You notice when I put in my x equals 0, I end up getting my independent variable. Good like that. After, you see, the independent variable is always a female, you know. She good like that. She have 2 men's. You hear what I'm saying? 2 men's walking back of her. All right. So one value of x gives me 2 values of y. Can you see that?
yes, sir.
She alone good like that. So when I look at this, I'm going to have x equals 0, y equals 0, x equals 0, y equals 2. This single value of x has outputted 2 values of y. This woman birthed twins. What? Remember, you know, don't do this out here, you know, because if you do this out here, you miss the x equals 0. Once you see something that you can factor it out. You will see it clearly. Notice that the x goes for both y's. So the critical points are going to be x equals 0, y equals 0, and x equals 0, y equals 2. If we had cancelled, we'd have lost that value. The x equals 0. Would have lost that, the y equals 0, I'm sorry, would have lost that value. So you have 2 sets of values for that. Question not finished yet. Because now we need to try for the y equals 1. So again, anywhere into the function I see x, I'm going to put y equals 1. I'm going to put my y equal 1. I'm going to have 3x squared plus 3 times 1 squared minus 6 times 1. I'm going to have 3x squared plus 3 minus 6. 3 minus 6 is minus 3. Again, factor out. Sigma common, factor it out. The 3 is common. Tani, see the question here again. Matter of fact, I think this was the exact question, Tani, that you asked me about. 3 common.
Oh, yes, sir.
Right. Exact question, but in a different context with a different question. The 3 come out. I'm going to have x squared minus 1. I reckon 3 cannot be equal to 0. No way time. Can't equal to 0. So I'm going to have now my x squared minus 1 to be equal to 0. Again, from last class, we recognize this to be the difference of squares. Come on now. So I'm going to have x plus 1 times x minus 1, which will imply that x is equals to 1 or x equals negative 1. Again, this woman has just given birth now to 2 more pygmy. So this one is going to be linking up with these 2. So when x equals 1, you know that the x value is written first, right? So that's why I'm starting with the x now. When x is equals to 1, y is equals to 1. When x is equals to minus 1, y is equals to 1. See here? Those are my critical points. So my x equals 0 gave me 2. My y equals 1 gave me 2. So these are my critical points. All these 4 something here are my critical points. All these 4 things are my critical points. All right? Now we need to do classification. Matter of fact, are there any questions? Are there any questions? Okay. So now, so from the question, I'm going to take up my f of x, f of y, y. I'm not interested in these again. Them two here, the first order is what I use to solve for the critical values. Remember though, from single order, single variable, that's exactly what we did. Now it is that I need the classification. So I need the second derivatives. All of these here, the second order partial derivative and the cross order partial derivatives are my second order differentiations. So that's why I write them out. I write out the second order x squared, y squared, x, y, y, x. I write by these out. Then so you have to write it to them? No, I didn't have to. I just needed one, but I know that two of them are the same. So I know my answer correct up here. So remember the formula? F of x, y, a, b times f of y, y, a, b minus f of x, y, a, b all squares. Watch me. I am looking, what is wrong? I have 4 points. Come on now. I have 4 points and I need to classify each of these points. Then, sir, nothing says only 2 stationary points you can get. We're lucky. Says only 4, we get some questions, give you many more. Certain 50 when you one of those, I doubt it. I really do. But you may get one of these to classify. They may not give you one where you get 4 points, but you may get one where you do a simple simultaneous equation that gives you x equals something, y equals something. That will give you 1 stationary point. That's what I believe they're going to give you. And then now you have to do the classification. So let us start with 0, 0. X equals 0, y equals 0. Let us look at our f of x, x. This is 6y minus 6. Oh, sir, but they don't have no x value here, so? No, they don't. So we're just going to substitute the y value. Oh, similar to what it is that we did, sir. In the single variable function, and there was no y value. So you just went ahead and substituted the x. So when I substitute 0 here, so this is going to be negative. So my f of x, x is negative. My f of y, y is also negative, sir. So we're going to have negative 6 times negative 6. And then my f of x, y. Sir, x equals 0. That means we're going to have 0 squared, sir. Yeah, so this is going to work out to be positive 36. Oh, but these positive. You said that once these positive, sir, it could be a maximum or minimum. But we have to check the value of xx. And if xx is positive, it's minimum. If xx is negative, it's maximum. But xx was negative 6. That means this one is a maximum at 0, 0. Let us check it. See? We got negative 6 squares. Xx was negative 6. Yy was negative 6. And xy is 0. I don't know why this is moving now. So recall we're making the substitution of the critical points in the second derivative to classify the nature. So negative 6 times negative 6 minus 0. 36 is greater than 0. But my f of xx is negative, so we have a relative maximum. Everybody see that?
Sure, you can do it again, please.
All right, watch me. Watch me now, because I'm going to ask you to do the rest for me in class. Because I'm not going to do another question like this. I'll give you 1 or 2 to do for homework in the interest of time. So I'm looking at the point 0, 0. I'm looking at the point 0, 0. I would have written down my f of xx, my f of yy, my f of xy or yx. F xy or yx. Now the formula says my d of AB, which is my critical point. That's why I put the critical point here, because I'm talking about 0, 0. So it's not, I'm substituting my critical point in here. So it's now f of xx 0, 0 times f of yy 0, 0 minus f of xy 0, 0. Why are you doing that, sir? To show you which of the critical points I'm using. But when I go to f of xy, f of xx 0, 0, when I substitute my critical points here, there is no x value. So I'm going to forget about the x value, but I'm going to substitute the y value. 6 times 0 is 0. So my f of xx is going to be negative 6. See it right here. So let us check for f of y.
So say putting in 0 wherever you see y in the equation.
Very good.
Okay.
So f of y, so happens is the same thing as f of x, still negative 6, times f of xy minus f of xy 0, 0. There is no y. So I'm going to substitute my x. 6 times 0 is 0. So that goes. Negative 6 times negative 6 is positive 36. I know positive 36 is greater than 0. The formula says, once d is greater than 0, it's going to be either a relative minimum or relative maximum. If d is less than 0, right off the bat, this is a saddle point. But if d is greater than 0, you have to now look at the value of f of xx. If f of xx is greater than 0, then we have a relative minimum. If f of xx is less than 0, we're going to have a relative maximum. So because f of xx in this case is negative, we're going to have a relative maximum. So my f of xx is negative that, so I'm going to have a relative maximum. Do you see, do you agree with this one here?
Sir, last minute.
Where did I lose you?
Why?
Talk to me now.
We get up.
Where is a while ago? Where? Oh, talk to teacher. Where is it?
Up on the part where you substitute 0 from this up. Yeah.
Oh, I don't know where up then, man. So you understand the simultaneous equation?
My last before that.
So JV, how we do?
We have to look over this.
You understand this?
Yes.
What's the next thing that we need to do now?
Solve simultaneously.
Very good. That means you know last right yesterday. So we're solving simultaneously. And then now we have one equation being linear and the other one being non-linear. So we're going to substitute the linear one. Remember the rule says we substitute the non-linear every single time. Substitute the linear into the non-linear. That's how we solve those equations. We have to substitute the non-linear into the linear. Marco, let me be honest. You don't have to. But if you don't, it may take you another 20 minutes to figure it out. I should be able to do it. Mrs. Henningham should be able to do it. But the easiest way to go about doing it is substituting the linear into the quadratic. And that's what I want to get you to do. So when you substitute the linear into the quadratic, I know you know how to do the simultaneous because we've done this already. To substitute the linear into the quadratic, come on, right? I'm gonna equate this to 0 as per usual. The first derivative equals to 0. And when I do that, I recognize that something is common. My 6x is common. So the common has been factored out. And when I factor it out, I'm going to get 6x times y minus 1. See it right here, so I'm going to set now equals 0. Either 6x equals 0 or y minus 1 equals 0. If 6x equals 0, that means x equals 0. And if y minus 1 equals 0, it means that y is equal to 1. So I have these two critical values, not points, critical values. It means then that each of these critical values must be substituted into the nonlinear equation in order for them to work it out. When I substitute this one in here, I'm going to get two values come out. This is my nonlinear equation. When I put x equals 0, that goes to 0. So I'm going to have 3y squared minus 6y right here. So when I factor out my 3y, I'm going to be left with 3y times y minus 2. Similarly to what we did up top, 3y cannot be equal to 2. That is just 0 straight up. Y minus 2 equals 0 is simply going to be y equals 2. So this x equals 0 has produced two values of y equals 0 and y equals 2. So I can therefore safely say that x is going to be equal to 0 when y is equal to 0. Or x is going to be equal to 0 when y is equal to 2. See here? And those are my two sets of critical values for when x equals 0. Right up here, so I've got another value for when y equals 1. So similarly, I'm going to put y equals 1 into the function, into my second nonlinear equation. Remember, not the original like we did in single order, into my nonlinear, and because I'm solving simultaneously while I'm doing that, and I substitute it into it, I'm going to end up with 3x minus 3 equals 0. Remember, we're not cancel. What we're doing is factoring. So when I factor out, I'm going to get the difference of squares, x equal 1, x equal minus 1. So this y equals 1 will produce two values of x. Watch me. The story says x equals 1 and y equals 1, or x equals negative 1 when y equals 1. Always remember that your x coordinates are written before your y coordinates. So it don't matter if we calculate y first. Y have to recognize what position y takes. Y takes the number 2 position. X takes the number 1 position. Once I'm writing my coordinates, x comes before y. You can't forget it. When you say A, B, C, x comes first, and then y after. All right? Now that I have my 4 sets of critical points, I must now determine the nature of the critical points. And that's exactly where I was when I stopped and asked if you're following. So those are my critical points. I'm trying to find the nature of the critical points. I chose 0, 0 first. What I'm looking at would be my f of x, x, f of y, y, f of x, y, f of y, x. If I'm looking at 0, 0, I'm going to be substituting the critical values into the function like we normally do to determine the nature. This is a second derivative. I normally substitute it into the second derivative for the single variable function. And if it is positive, it's a minimum. If it is negative, it's a maximum. For the multivariable function, we do it slightly differently. Just a slight difference. We're going to find f of xx times f of yy minus f of xy, all squares. F of xx, and I substitute my 0 here. I'm not substituting the x value 0 because there's no x here. So let's go ahead and substitute the y value. If there were an x in here, I'd also substitute it. So 6 times 0 is 0. So my f of xx works out to be negative 6. See here. And my f of y works out to be negative 6 as well, because both functions are the same. And my f of xy, which is also equal to my f of yx, is going to work out to be 6x. So 6 times 0 is 0. So all of that goes to 0. So that's why I have the minus 0 there. And negative 6 times negative 6 is positive 36. And because f of xx is negative, See it right here, so I'm going to end up with our relative maximum. See it right here, so any clearer,
Sir,
Gabriel?
how you have 6y minus 6 squared if minus 36x squared?
Yeah, because what I'm saying here is f of x times f of yy. So I'm multiplying this f of x times f of yy. So that's why I say 6y minus 6 all squares from there. And then now, if f of xy is 6x all squares is going to be 36x squared.
Oh, okay.
But yeah, I don't have to put it there. If it's going to confuse you, let me take it out. If it's going to confuse, let me just remove it.
No, sir, not confusing me. No, I just wanted to know why it was there.
Okay, all right,
Where you got it from.
okay, no problem, man. So let it stay then. All right. Now that, are you all seeing what is happening now? Okay. Thank you for answering.
Sorry, you say it's a relative maximum because
F of x is negative.
okay.
So now, what I want you to do for me now, we have 3 other points to look at. I'm going to leave this open right here, so, because you have your f of xx, you have your f of yy, and you have your f of yx. What I want you to do for me, let me just go down. The other point is 0, 2. So you can just write 0, 2 for me, please. Well, just write the points down. Write down the points first. I don't want to show you the answer because I want you to get your practice on it. So write down the points first, so please. And when you write down the points, let me know if I can just project it at that point so you can start working on those 3 for me. Thanks. Thank you, thank you. Why you just changed over quick time? You couldn't even ask if you changed over.
Yes, sir.
All right, thank you, dearest. I got kicked off. Thanks, Shanti. Make sure you guys are working now. I know the class is heavy, but we have to do this. So just at the prize at the end of the tunnel. Work, work, work. Thank you. I think that I have an idea what some of you are doing.
Sir, question.
Mhm.
So where the minus fxy squared, what should you do for that part? Yes,
Substitute the
that
value.
part.
You might substitute the value in it also. Remember, f of xy is 16 or 6x.
Yeah.
So for the 0, 2, I'm hoping that you all did 0, 2 first.
Yeah.
For the 0, 2, you're going to substitute the 0, 2 into that. But remember, x is 0. So this again is going to be 0 because if x is 0, remember now, the first value in the set of ordered pairs will be x, and the second value in the set of ordered pairs will be y. So it will be 6 times 0, which is 0 again. And this one here is going to be 6 times 2 because y is 2. So 6 times 2 is 12, and 12 minus 6 is 6. So this is going to become 6 times 6. We're still giving a positive 36, like the first one. But in this here case, f of x is positive. So this is a relative minimum.
Yes, sir, I got it. I just I never understand the
f of
Oh,
x.
you're not supposed to work it out.
You just, you work it out, But teacher can hear, but f of xy, is
Sir,
x
so
is
what if
0,
what if it had a number in there?
If it had a different number, you work it out. So this is my 36 minus whatever number it is.
Okay.
All right, hold on. Look at what 1, 1 is. Is it 1, 1? Look at what 1, 1 is. X is 1, y is 1. There is no x, so you can put your y to be 1. 6 times 1 is 6. 6 minus 6 is 0. And this one is going to be 0 also. That's why I have the 0, 0 here. But x is 1, so 6 times 1 is 6. But 6, 6 is 36. So we're going to have 0
So
times 0.
the squared, you're supposed to add, you're supposed to square it, or
Yeah,
it's
man.
just doing. Oh, okay.
So it's always squared, but it's just that because this is 0, I never put 0 squared. Figure?
Oh, okay. Yeah.
Right.
Okay.
And then now you're going to end up with 1, 1. You're going to end up with 0. 0 times 0 is 0. 0 minus 36 is going to be negative 36.
Yes,
Negative
sir. That's what
36
I
is
got.
less than, yeah, man. So you have a saddle point. All right. So I'm going to need the last one for you to do for me. The last one is 1, negative 1. Negative 1, 1.
Sir, yeah.
Yeah, negative 1, 1. All right. I'll give it 2 minutes to do that one, please.
Sir, I'm gonna try to know.
Yes, sir. I did it.
You did it? Okay. What you got for it? What you
Yes, sir.
got? What is the classification?
I got negative 36.
So that means a saddle point again.
Yes.
Very good. Yes, please, Natty. All right. Okay.
Sir,
So
what
this
did you say the saddle point is again?
is I will show you on a graph for next class. But what I will say to you is think of you putting on a saddle on a horse. That's something that they put on
Sir,
the back
not
of the
that
horse.
as in for the narrative that you wrote up at the top.
Okay,
Yeah.
okay. Yeah. So when it is when D is less than 0, it becomes a saddle point. Let me
Okay,
scroll up
sir.
and right.
Okay.
So when D is less than 0, it's a saddle point. When D is less than 0, it is a saddle point. So once you get D to be equal to 0, you have to check nothing else. Saddle point. If it is positive, check the value of xy. F of x, I'm sorry. If x is positive, you have a minimum. If it is negative, you have a maximum.
Oh, sir, I went ahead and I did well, I put 0 equals 0 because that's basically what I got. So that's why I knew it was a saddle point. So I was wondering what was the difference between them.
When it says 0 equals 0, what do you mean?
The additional step. I think you did an additional step for 0 0, the first one that you did.
Which step? Oh, right here?
Yes, right there.
Okay, yeah, man. Same difference. Same difference. Same difference. All right. One of the things that God has given us is something that is called discernment. And it's not any and any discernment at all. This one is of the highest order, spiritual discernment. And I discern that you have had enough of spending time on myself for tonight. Please do not respond. Please do not
Yes,
respond.
sir.
Please do not. To crush our feelings. Yeah.
You know, we just look on the road from outside.
Oh, yes, sir. Are we here talking? Or are you having other conversation?
Talk to say we just tell us we're tired because we have to go to school today, then come back and.
Oh, you were on the road. Okay. You saw like nothing. You saw like nothing. Yeah, man, I understand that. I understand.
Like me.
Yeah, I understand. I'm not doing anything else. I just want us to use this last 10 minutes of the class, or 9 minutes, or 8 minutes, whatever it is, to just relax. To relax. Some of you have been relaxing because you decided to not pay me no mind from a long time. But we're inching a little bit closer. We're inching a little bit closer. I just have integration to look at now. And on Friday, God's willing, just dedicate the class to integration. Dedicate the class to integration. Students, I want you to commit to the task of your mathematical revision.
So it's a Friday.
Rockstone. No.
Right.
No. Friday, me and Papa Jesus, we have a date. Yeah, no. So, importantly, is that we need to make a connection between a vertical connection between us and our Savior. And as I go, I remember, when I was studying at the university, I don't miss church. Like some people say, oh, they're not going to go to church because they have an exam tomorrow morning. Oh no. He is my source, and me have to depend on him in the exam. So me going to dark myself to church. If we not finish studying for my exam, it's not his fault and my procrastination, right? And that's why I can identify laziness, because trust me, I know what it is like. All right, so I am the first to tell you who I am. Lazier, procrastinator, and then now you make the work pile. It's like, show me after do nothing right and now I can. And then when the labs them pile up on you, and then you have this pile up and say, oh my God, and then you go through them. When you get that 7 out of 10, you could have said, John, if you have more time, I could have get that 8 out of 10 or a 9 out of 10, right? The story of my life. But anyhow, so when I see it, I can identify it. And Johnny's son, when teacher say you can do your work and lazy, don't personalize it. It's because Sir himself can see it. And I mean, no, if I ask you to speak honestly, you're going to say, Sir, but you're not telling a lie about the truth. No, Johnny.
No.
Good answer. But anyhow, so the truth of the matter is, though, we procrastinate a lot, and procrastination can make us and it can break us. It can make us, and it can break us. Now, what I want you to do is to commit yourself to the task of just being what you're supposed to be. And I'm not here in any way, shape, or form putting down any other subject matter. You're not doing sociology or management of business or history or literatures in English or, then subjects where you can literally read and put to memory and decide that, yeah, I can go and do the psychology and explain something in my get a one. And I will forever say, when you have a science student who can do very well, and you have a non-science student who's getting that, if I have a science student who's getting twos in chemistry, biophysics, and math, and I have a non-science student who's getting ones in 4 other disciplines, you know who I lift my hats to? The science student, because these courses are much harder than the other courses. I'm not saying that the other courses are not hard. I'm saying that they are much harder. I know it is rough when I ask you. I have been there. I have been there. A science student myself, I have been there. One time I want to jump out of my eye. And a one time he said, this university life is not for me. No. Me don't find one word. And then they remind me, say, is Upi again? And then I have to just crawl back into my shell and recognize them in a rich man would yet. So I'm still on my caring soul and then tell me the doom I have to do. Alright? So class at Little University, them tell me not like people write about no me that think about me I got no first degree. Oh, no man, crazy. But I just had to stick with it. It was rough, but I had to stick with it. And I'm going to say to you, it is rough, stick with it. No, Mrs. Henningham can sit back and look at it and say, wow, just look at that. I can sit back and say, wow, look at that. Rough time. Finally, I went to a swim meet on Saturday. And while I'm there cheering all the people, them and said, Chuck, I feel like more jumping on the pool to go do a little 1 lap or 2 lap. And I turned around and saw one of my friends eating a penny bun and a patty. And it brought me right back to my high school days. I mean, I just stood up rather, I was standing, I stood up and I just started thinking back of my high school days. When you go to school and hungry, bite your shut. And you not bite from the cafeteria, you go through the fence and say, you guys are good students, so you never used to do those things. And I go through the fence and say, oh, send me a bun and corned beef. And people may say, bun and corned beef, sir? It was the nicest thing ever, them times there.
So what you mean, well, a corned beef?
What do you mean?
What you mean, like one tin of corned beef or some corned beef in a bun?
No, but just put the man cook up the corned beef nice, and then him just butter the bun with the corned beef.
Oh, okay.
But then the days before Gilbert, when we used to eat corned beef, he did nice, man, nice and fresh. Oxtail not taste nice, so. And when you have like extra money in your pocket, and you can graduate from the corned beef, you go buy one patty. And put it in the bun. Yeah, man. Bun what? You must, when you not live life, you know.
I mean,
sir, no, sir.
Thursday you couldn't just eat the patty alone and save the bun money.
You say, when you not live life. No, so when you eat patty and cocoa bread, when never save the cocoa bread money.
So I'm gonna eat patty and cocoa bread.
Sir, that different. Sir, the whole of the flavor just throw off. The bun sweet and no, sir.
So if me eat patty, me eat patty, and if me eat cocoa bread, me eat cocoa bread.
All right then. One must try it one day. But the point though is, and sometimes when you buy a patty and bun, you don't have nothing to drink with it because you can't afford a box. So you go drink the water and wash
That's why you should buy no bun.
Bun, exactly.
You want your belly full. You want your belly full. No. You want your belly full, even patty just nasty petite. No man, you want bun with that too.
So now that's why you eat the cocoa bread, sir.
Bun nice. But you know, the truth of the matter though is when you look back at those days, and I mean, a little later on
Sir,
in life,
which bun you talking about? The regular round bun?
it said one.
No, no. Sir, back when I could have had it, I've tried patty and bun, but it was the long one.
Mm-hmm.
And it did taste nice without the raisins and all that.
Don't
But I'm
taste
not
like
too sure about the round bun.
no man, it bun a bun. Bun is bun. Bun is bun when boyfriend eat
Sir,
the
the
bun, when he eat
flavor
the
of
bun,
the long bun
it's the
is a
same
lot
bun.
different from the round bun.
Give me, bun is bun. When somebody burn you, when you eat the bun, it's the same bun. Bun is bun. But anyhow, the point though is the truth of the matter is you know, we will have our own struggles. Some of you may have struggle of finding bursary for go to school, space, school fee, lunch money, struggles just to study, etc., etc. Whatever our struggles are in life. But I'm going to tell you, and this my parting words to you tonight is that when you have a relationship with God and you commit those struggles to Him, and say, God, I don't understand what is blocking me from understanding matrices or simultaneous equations, and you pray to Him and ask Him to clear those obstacles. Trust me, He will. And I'm depending on you. Don't sit down in your misery. This is Henning and is part of the WhatsApp group. I am part of the WhatsApp group. I'm gonna drop in a question now. At this point in time, when I'm supposed to be working, drop the questions. Can somebody explain?
Sir,
Yes, please.
sir,
Go
you
ahead.
sound tired out. You sound tired out, yeah?
No, but I'm saying to you, no, Mark, and this is why I said that I wasn't going to come back to teach anymore CXC, CAPE, or CSEC, because of the sort of pressure that it brings, right? And this is why I had moved away from it. And I mean, I only came back to CXC this year with you guys. I used to teach it every year, right? And I took a go to, yeah, I shouldn't say that I took a break because I was teaching ADMA, which is also a CXC subject, right? But the point I'm making is, I am telling you, put the questions in the group. I'm not putting myself under pressure. Put the questions in the group because the end of the day is that you guys are going to benefit from it. I know some of you are suffering from lazy man-ritis, and I'm going to tell you, wake up, get up. When I was doing A levels, it is round about this time that my bed and I were in malice. And I took my mattress and my bed bottom and I put it to the side of the wall. And I cut my eye off of them. And what brings on serious memory, students, is that your math is on the second, your other one, the Miss Barton's course is on the fourth, which reminds me so much of when I was doing an exam. Within the first week of A levels, all my exams were done. 2 and 3 papers a day. Done. Every day for the week. Done. Right? So just stick with it. Remember, your aim is to get an associate degree. Integrated math is an important ingredient for you to be awarded the Associate of Science in CXC. If you don't have the integrated math, you're not going to get it. So don't fail me. Don't fail yourself. I believe in you. I honestly believe in you. And which is why sometimes I come to class and I may put you under pressure, I may rub you away and so forth, but don't internalize it. It is a strategy. It's just to get the best out of you and for you to believe in yourselves. All right. Final now. Natty B and Johnny Boy. It's the next class. Want to make sure you come to class early. And it goes with everybody else because we're starting on time. I will communicate with you. We're not meeting on Friday. Friday is Good Friday. Then we're going to have Good Saturday. Then I don't think we're going to meet on Saturday because it's Good Saturday. we have Good Sunday and then Easter Monday. So, oh Lord Jesus. Anyhow, we'll talk. Have a good one. Say drink for Jesus, please. And be good and be safe.
Bye, sir.
Bye, sir.
Bye,
Same to
sir.
you.
Come on. Cool.
Bye, sir.
Come on.